Hey, so this is the Cobra 29LX that I picked up from the States a little while ago, and I really like the look of these things, so I thought I'd have a shot at modifying the radio a little bit. It's AM only, so again it's a bit of an overkill for what it is, but it's a lot of fun. So I really liked the idea that these things have got a frequency readout on the front. It means that you don't have to have look up charts and switches and what have you to get extra channels. You can just dial any frequency up that you want. So very handy, and it was a good thing to have a play around with. So the first thing that I like to do is to put the sub channels in. So the 3A, 7A, 11A, etc. So these were the channels that were back in the day. They were the sort of the only clear channels that you could get when the CB was completely crowded with thousands of people. Not like that anymore. You're lucky to find anyone, especially on AM in Australia anyway. So adding more channels is really probably the main thing that I wanted to do, just have a bit of a play around with it. When you get so what I did here, when you get up to 41, it starts to go in 5 kc steps. So it'll, you can step through all the zeros if you want. Again, it's especially up on these frequencies, it's going to be sideband only, so probably not much use to have that on an AM only radio. But it was more of a sort of just a bit of fun, a bit of a challenge to have a play with the radio and see what I could get out of it. And then after 99, you up into the 10 meter amateur band, and so don't worry about displaying the channels up here, and it will receive reasonably well. The front end on the receive on this, I haven't done anything to it, so it receives pretty well from about 26.3 to 28.3. After that, it kind of rolls off pretty badly and becomes quite deaf. So, but otherwise, it's reasonably sensitive in that range. I think I've left it to go from about 25 to 30 meg at the moment, but it's completely deaf after about 20. After you get below about 26.3 or something like that, it's kind of just rolls right off. So yeah, the transmit on this is actually really wide. Like there's hardly any change from about 25 and a half meg right up to 30 meg. It sort of transmits on full power all the way through there. Full power being 4 watts. All right, I'll show you what I've done on the inside. Forgot to mention, we don't have the weather channels here in Australia. This thing has got 10 weather channels, around about 161, 162 meg. They are weather warning or weather report channels for the States, and we don't have them here. So I repurposed the receiver that does that. It's a separate receiver. I repurposed that down to the 2 meter band, so 144 to 148 meg. It's FM, so it works okay. It's not the best receiver, but it's better than nothing. I mean, the 10 channels for weather in Australia are pretty useless. So when you switch to weather, it says weather, but you can see it's on 145 meg. That'll go from it tunes from 144 to 154. I think I made it. I just had to tune the VCO down a little bit to recenter it because it dropped out before that. So I just recentered it, and it covers that whole band reasonably well. And it's actually not too bad. It receives okay, better than nothing, and obviously better than the pretty useless weather channels that we had that we don't have here in Australia. Okay, so this is what it looks like on the inside. I pretty much gutted everything here. This originally had a masked 40 channel PLL in here. A VCO was here. That went through to a VCO, a transmit mixer here, where it mixed the 16 and the 10 meg to get 27 out. It had the VCO was here and here. Transmit mixer chip was here. Got rid of all that. With these 5351 boards, I can now generate the 27 meg, which comes straight out of here and straight through to the transmit. This is the 16 meg, which comes back through here to the first IF, down to 10 meg. And this output, the third output on here, is the 10 meg, which mixes it in and gets the 455 kilohertz and gets demodulated through there. I switch these on and off for transmit and receive appropriately, so they just so that you know, less harmonics and don't interfere with each other or whatever. This is an ESP32-C3 board. I needed that for the speed. I tried it with a Nano, but what I'm doing is I'm actually hijacking the display for putting what I want on the screen, and the Nano was nowhere near capable of the speeds that were required for the interrupts to hijack the data line. So this thing has no problem at all. So this controls this PLL, VCO PLL board, and it also controls this, it's underneath, but there's another PLL under here for the weather channels, which is now the 2 meter band. I changed the clarifier, delta tune, whatever you call it. I changed that to do 3 kc each way on transmit and receive. So I guess it's got an AM with an unlocked clarifier in it, and that's just to center the clarifier. And it's got a dead spot in the middle, so it doesn't drift around. Yeah, it's about it in there. I'll show the other side. Okay, so this is the other side of the board. The Si5351 sits across these pins here. The PLL, the I2C hooks into that through here. When I pulled that ribbon cable out, this ESP32-C3 board dropped straight into the 2 sets of pins that were where the ribbon cable was, so that was really handy. I tapped off the I2C line and run through to this. This is another PLL chip. This is for the weather channels, repurposed for the 2 meter band. This is just a simple divider for me to get a transmit TX-RX line in at around about 3 volts. These 2 lines are for the rotary encoder, so I just tap off the rotary encoder here. I left the original rotary. I left the rotary encoder hooked up to the original CPU as well because, as I said, I'm just hijacking the display, so I didn't want to rewrite all the software for the menus and all the rest of it. So couldn't be bothered. I just tap into the display. These 4 lines here are the display lines, so I basically monitor what's going on with the display, and at the appropriate time I just hijack one of these lines, which is the data line, and I just rewrite my data onto the data bus where at the right time. So, and the ESP32 is capable of those speeds. This thing, the original software updates the display like 9 times a second or something like that, and a lot of bytes and a lot of bits in there. So yes, it needed something reasonably fast to do that, and all seems to work okay. All right, I'm not sure what the next radio will be that I have a look at, but I've got quite a few. So as I said, this is again another overkill. It's don't do this at home. It's just not worth it. But it was a lot of fun to do, and it was just really an experiment in electronics. So I really enjoyed it. I'll see you next time.